A schematic file sits on the table, not a chip, but the file that tells a chip what to be, rendered in a domestic Chinese electronic design automation tool, timestamped to a state-coordinated initiative that began accelerating in early 2026 in Zhejiang province. The object we are opening is the layer that precedes silicon, the software stack that translates an engineer's intent into a mask set, and the organized effort to rebuild that stack entirely from domestic sources after the United States made clear that owning design software was a precondition for owning anything else. Peel back the initiative's surface framing and the layers underneath show something consistent with every prior Chinese response to a hard restriction. The restriction itself becomes the architectural specification for the replacement. The cuts move from what Zhejiang announced to what electronic design automation software actually does and why it resists fast replication, to what domestic alternatives currently cover and where they stop, to the deepest layer, what the shape of the gap reveals about where the ban landed and where the engineering effort is now concentrating. Zhejiang province launched an accelerated electronic design automation localization program in early 2026, explicitly framed as a response to United States export controls on design tools. Chinese chipmakers participating in the initiative are actively redirecting development workflows to domestic platforms, not in a pilot study, not in a roadmap document, but in running design operations. This is a documented, state-coordinated industrial redirection, and its provincial framing carries a fact the announcement does not state. Zhejiang is home to a concentration of fabulous design firms that were already operating closest to the ceiling imposed by the ban. Placing the localization effort here is not symbolic geography. It is positioning the hardest working test cases directly against the domestic tools, which surfaces gaps faster than any controlled laboratory evaluation could. The outer shell establishes the moment, the Chinese state formally treating design software as a strategic vulnerability requiring the same organized response previously applied to hardware. The organizational grammar of this initiative, state coordination, accelerated timeline, explicit targeting of a restricted category, matches the grammar of China's responses to equipment restrictions in lithography and advanced packaging. Read anatomically, this is an admission that software dependency is structurally identical to hardware dependency, and that the same playbook applies. One layer down, the question is what electronic design automation software actually is, and why it resists rapid replication. The full pipeline spans logic synthesis, physical layout, timing closure, design rule checking, and verification against a foundry's process design kit. The three dominant Western vendors in this space, Synopsys, Cadence, and the firm now operating as Siemens EDA, have accumulated decades of algorithm development, process node-specific tuning, and co-development agreements with leading foundries. The complexity is not primarily in the volume of code, it is in the calibration. Each tool must be tuned against the specific electrical behavior of a specific process node, which makes the software and the fabrication facility codependent. Independent benchmarks of domestic Chinese tools against leading-edge process nodes are sparse. The company claims that exist have not been confirmed by third-party fabrication results at advanced nodes. This layer exists in the object because the band's designers understood the codependence. Restricting access to design software is not the same as restricting access to a machine. It is restricting access to decades of calibration data embedded in the tool. Calibration that only exists because the tool was used, revised, and used again against real process nodes in real fabs. The difficulty the Zhejiang initiative faces is precisely here. Domestic tools must be recalibrated against Chinese foundry, process nodes, and the foundries capable of advanced nodes are themselves operating under separate equipment constraints that affect how precisely they can characterize their own process. The next layer down is what domestic Chinese electronic design automation vendors currently cover and where they stop. Firms including Empyrean and a cluster of smaller domestic developers have established credible coverage at mature process nodes broadly understood as 28 nanometers and above. Chip makers in analog power management and display driver segments have used these tools in production. At leading-edge digital logic nodes, the evidence is thinner. No independent fabrication result has publicly confirmed that a domestic tool achieved successful closure on a leading-edge node tapeout, and the company claims in this range have not been externally verified. The Zhejiang initiative's acceleration is targeted specifically at this gap. The state is funding not just tool development, but the active integration of domestic tools into real design runs, because that is the only way to accumulate the calibration data the tools currently lack. The gap's location is not accidental. The export controls were tiered, and mature node tools remained available longer. What the gap exposes is the exact contour of the restriction's precision. It was aimed at the leading edge, and that is exactly where domestic capability thins out. The initiative's acceleration at this layer is China responding to where the calibration is missing, not to where the code is missing. Calibration data of this kind accumulates the way sediment accumulates at a riverbed. Each process generation deposits another layer, and the layer below determines where the next one settles. You cannot extract the sediment and reconstitute the riverbed quickly. You have to let it settle again, in the new river, under the new conditions. The Zhejiang initiative is China diverting the river and waiting for the sediment to settle on domestic ground, and the timeline is not set by will or funding alone, but by the physics of accumulation. The verification gap at advanced nodes is not an abstraction. It is the number of design rule violations that go undetected by an uncalibrated tool, violations that do not appear until the wafer returns from the fab with a yield that does not match the simulation. That yield gap is a physical object, a tray of dies that do not function, each one a data point that improves the calibration for the next run. The deepest layer of the Zhejiang initiative is what its organizational structure reveals about how the ban actually landed. A restriction on a physical machine creates a hardware gap that is visible in a factory. A restriction on software creates a calibration gap that is invisible until a design fails at tape-out, which means the gap was not fully legible until Chinese chipmakers pushed domestic tools against the most demanding design rules and found where verification broke down. The initiative's acceleration in early 2026 follows this discovery cycle. The ban took effect, domestic tools were used at the boundary's location became visible in the failures, and the state response was organized around the exact coordinates of those failures. The initiative is a negative image of the export control, shaped precisely to the control's outline. Its funding targets, its provincial concentration, its timeline, and its reported capability gaps all trace the contour of the ban's most precise interventions. What this dissection cannot settle is the pace at which calibration accumulates once the initiative is fully operational. The codependence between design tools and foundry process nodes means that the quality of calibration is bounded by the quality of the foundry data, and Chinese foundries at advanced nodes are themselves operating under equipment constraints that may limit how precisely they can characterize their own process. If the foundry's process design kit is incomplete, the tool calibrated against it carries that incompleteness forward into every design that uses it, and no amount of software development resolves a gap that originates in the fabrication facility. The initiative's own timeline claims have not been benchmarked against independent tape-out results, and the distinction between a tool that passes internal design rule checks and a tool that produces working silicon at volume has not been publicly closed for leading-edge nodes. There is also a question this dissection cannot answer from the outside: whether the Zhejiang initiative is accelerating a trajectory that was already underway, or whether the export control created genuine urgency that was not present before. The policy framing says the latter, but the underlying engineering investment in domestic design tools predates the ban by several years, which complicates any clean causal story. What the dissection can say plainly is this: the initiative's existence confirms that the ban identified a real dependency, and the initiative's structure confirms that China read the identification the same way. The specimen is real, the gap it is organized around is real, and the pace of closure is the one quantity this dissection cannot determine from the available evidence. Taken as a whole object, the Zhejiang initiative is not primarily a software development program. It is a state-legible map of where a foreign restriction found genuine purchase, and a structured commitment to ensure that the same purchase point does not persist into the next technology generation. The restriction worked well enough to be visible in the response. The response is organized precisely enough to show that China read the restriction's intent, not just its text. What the layers prove, cut by cut, is that a software export control and an industrial localization initiative can be mirror images of each other. and that the mirror was cast the moment the restriction took effect. The next object on the table could be the process design kit itself, the foundry side data package that design tools are calibrated against, or it could be the domestic verification tools China is building to close the tape-out loop without foreign sign-off. Which layer would you open next? If this kind of systematic dissection is useful to you, subscribe. Each video puts one object on the table and does not stop cutting until the deepest layer is visible.